Hi, my name is Akhil Patel. I am from Aeronautical Engineering. My topic is about condensers. Condensers. Heat exchangers are used to transfer heat. Some process like heating, cooling, and condensation, boiling, or evaporation are the heat changing process. Different heat exchangers are named according to their applications. For example, heat exchangers used for the boiling purpose are called the boilers, and the heat exchangers being used to condense are called the condensers. The condenser is a heat exchanger that usually rejects all the heat from the system. The condenser accepts all the hot, high pressure refrigerant are usually a superheated gas from the compressor. The condenser is usually air cooled by natural or the force increases the cooling effect of the condenser. The function. The purpose of the condenser in the refrigerator system is to remove heat from the refrigerator vapor, leaving the compressor or generated in case of the absorption system, so that the refrigerator will condense to its liquid state. This liquid refrigerant will then be able to achieve the refrigerating effect in the vaporization. Working of the condenser. In a typical refrigerant condenser, the refrigerator enters the condenser in the superheated state. It is first superheated and then condensed by rejecting heat of an external medium. The refrigerant may leave the condenser as the saturated or the subcooled liquid depends upon the temperature of the external medium and the design of the condenser. This is the process of the evaporation, and this is the pH diagram of the condenser. Classifications of condensers. Mainly condensers are three types. First one is the air cooled condenser, and second one is water cooled condenser, and the third one is the vapor active condenser. In air cooled condensers, naturally conventional cooled air condensers and forced conventional air cooled condenser are the two types in the air cooled condensers. And in water cooled condensers, there are three types: tube in tube or double tube condensers, shell or the coil condenser, and the shell and the tube condenser. In vapor condensation, there is only one method, that is the vapor condensation. Air cooled condensers. Air is used as fluid for cooling purpose, that is, refrigerant reject the heat to airflow over a condenser. Further classifications are the natural conventional type. The finite type condenser are mounted either below the refrigerant or at the angle or on the back side of the refrigerator. In case it is mounted below, then the warm air rise up and to assist it, an air envelope is formed by providing a jacket on backside of the refrigerator. The fin space is kept large to minimize the effect of folding by dust and to allow air to flow free with little resistance. And we generally see the backside of the refrigerator, we have find this one in shown in the figure, which is used for this. A thin wire are welded to the suspense tube coil. The wire act like fins for increasing heat transfer area. Wire and tube type condensers are commonly used in domestic refrigerators. Hence, these condensers are used for the small capacity refrigeration system like household refrigerator and the fridges. In forced convention type condensers, the circulation of air over the condenser surface is minimized by using a fan or a blower. We generally see in some refrigerator there is a fan to throw out the hot air from the refrigerator. This is the forced convection process. These condensers are normally used fins on the air side for good heat transfer. The fins can be either plastic type or the annual type. Sorry, plate type or the annual type. Forced convection type condensers are commonly used in windows, air conditioners, water coolers, and the packaged air container plants, etc. In water cooled condenser, first one is the double type tube in tube type. The double pipe condenser are normally used up to 10 TR capacity. The cooled water flow through the inner tube, refrigerant flow through the annual in counterflow. The headers are used at both the ends to make the length of the condenser small and reduce pressure drop. The refrigerator in the annual rejects a part of its heat to the surroundings by free convection and the radiation. The heat transfer coefficient is usually low because to poor quality liquid refrigerator drains if the tubes are long. In second type, the shell and the coil type, these condensers are used in the system up to 50 RT capacity. The water flow through multiple coils which may have fins to increase the heat transfer coefficient. The refrigerant flow through the shell. In smaller capacity condensers, refrigerant flow through coils while water flow through the shells. When water flow through the coils, cleaning it is done circulated suitable chemicals through the coils. Shell and the tube type. In this third type, we used 2 TR up to 1000 of TR capacity. 2 to 1000 TR capacity tubes are we are using. The refrigerant flow through the shell while water flow through the tube in a single flow four passes. Like we see in the figure, there are the four passes. The condenser refrigerator collects at the bottom of the shell. The liquid refrigerant is drained from the bottom of the receiver. A vent connecting the reservoir to the condenser for smooth drainage of the liquid refrigerant. The most common type is horizontally shell type. Vertical shell and tube type condensers are usually used in ammonia in large capacity systems so that the cleaning of the tube is possible for top while the plant is running. In vaporization condenser, both air and water are used to extract heat from the condenser refrigerant. Vaporactive condensers combine the features of cooling towers and the water cooled condenser in a single unit. In these condensers, the water is spread from the top part of the bank of the tube, carrying the refrigerant, and the air is induced upwards. There is a thin water flame around the condenser tube for which vaporactive cooling takes place. The heat transfer coefficient for the vaporactive cooling is very larger, can be operated at low condenser temperatures, about 11 to 13 uh, at 11 to 13 kelvins. Also we use it for the above wet bulb temperature here. The role of air is primarily to increase the rate of the evaporation of water. The required air flow rate are in the range of 350 to 500 meter per hour for TR of a refrigerator capacity. Thank you. This is about my concept video.